Alright, so this next video is continuation, obviously, with Arnold rendering. This is where we left off, and I had introduced you to the Arnold imagers. AI imager denoise optics 1. Okay, boom. Right, here's our render settings under the Arnold render tab, second tab, not this one, this one, under our imagers, right? And which this render settings, we also call it render globals. Render settings, render globals is interchangeable. What the hell is this? Whatever. And this one right here is the tab to open this up. Okay. Anyway, here's our Arnold render, right? And the way you find that is under Arnold, open Arnold render view. Right, this one, not this one, this one. And then, and this guy right here is to save a snapshot. If you don't see it, it's like that. All right, so quick review. Now, next critical thing I want to share is under ray depth, right there, ray depth. It says here diffuse and specular. These two, whatever you do, have them at least set to 2. Alright, so I paused the video for a bit to let the computer render, because I had moments where when the computer renders, it messes up my video tutorial and I just end up losing a lot of time. So here's this is the after doing 2 diffuse and 2 specular, right? So before, it's okay. And then when I click on that, that's my old render. If I let go of it, this is my new render. New render, click on this, old render, unclick it, new render. See how much brighter it is? So this is an example of our secondary bounce, hence 2 bounces on our ray depth. All this fancy words, it just basically means how many bounces. They should just say over here, light bounces or something, But regardless, diffuse, meaning the diffuse is going to have 2 bounces, and then the specular is going to have 2 bounces. If you really want to get in depth about diffuse and specular, just Google it for diffuse and specular for 3D rendering, and you can read through all of it. It's technical stuff, but basically specular is the shininess, right? You see the shininess. This is reflectivity, but it also has to do with the shininess. So the specular has to do with the shininess and how many times when the light source hits it, it bounces off and causes another shine to it. More or less, that's what I think. And diffuse is just the generality of the diffuse lighting to get a second bounce. Yeah, these two are different, but they work together, you could say. All right, so before, after. Here's the before. See the shadows here. And after. Very nice. If you look here, see how dark that is, right? And after, you see that? You see that right here? The difference in the shadow tone, right? Core shadow, lighter, and the shadow color bleed is here too, where there's a blue tint to it. Very nice. I like it. Alright, so that's this and this. Very, 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 very important to get very nice renders. Alright, so we did that. Next. Alright, so I wanna go over some of this. The Arnold render view interface, right? Down here, this here, it represents how long it took to render. This here represents the size, the resolution size. Right now set to 960 by 540. For your demo reel, you could get away with this, right? Because the bigger that your resolution gets, the longer your render times take. It's a huge deal. This here tells you what is rendering your image. Is it your CPU, like your Intel or your AMD computer chip processor, okay? Or is it a GPU, meaning like your graphics card? And just for shits and giggles, I'll show you what that is. CPU. Alright. So this is a CPU where it's the pretty much the brain of your computer, and it sits on the motherboard, and your CPU usually does all the processing, computations, and all of that. But then there's also your GPU. This is not always in every computer, where it's a graphics card. It's a secondary item where its main purpose is to process the graphics, for example, like for a video game or for 3D animation, stuff like that, and some of it for video editing and After Effects, motion graphics. Yeah. So this is the GPU. It gets plugged into the computer, the motherboard, to be part of the computer system. See? So if it's GPU, let's say GPU. And then to turn on GPU, it's under render settings, right? Render settings again is this guy right there. Click that. You have your common tab, Arno render, and your system. I'm going to just close all of this so it's not too distracting. Right here, render device, device selection, render device. It is currently set to CPU, but if you click it, you can set it to GPU. But I don't want to do that right now. It might crash my system. Once in a while, it'll do things like that. Okay, so that's that. And you see how when I made changes, the rendering updated, right? Automatically. That's because of this. Hold scene updates. This thing right here that looks like a Wi-Fi signal, that is your interactive renderer. Interactive progressive renderer, IPR. This is your play to start a render. And this here is your 1-to-1. Let's say if you zoom out by accident, press that, boom. This here is to do selection, certain selective area rendering. See, and it'll only render a little patch area for you. I used to do this a lot when I had slow computers. And then you can unclick that, or if you unclick it, it'll render the whole thing again. Alright, so that part's a little bit annoying. This here is your alpha channel for compositing. We'll do that later. This here is your RGB thing. I don't want to mess with that. Next important thing is this tells you which camera it's going to render from. It should be set to perspective, but sometimes it'll pick something else by accident. Always just make sure to know which camera it's on. This is your, you don't have to screw with that. It's fine. And down here shows again, back to here, your perspective, which camera is being rendering, your samples. This is your renders samples, meaning like the quality of it, which is basically under your Arnold renderer, right? So I know right now I'm just kind of talking like mumbo jumbo, but this here, 3 2 2 2 2, this is over here. Sampling 3 2 2 2 2 2, 3 2 2 2 2 2. That's what that is. Sampling. And what does sampling mean? I'm gonna hide that, hide that. Sampling, this here basically means how jaggedy your image looks. You know, does it look like anti-alias, like bad anti-alias, where it looks all jaggedy? And it has to do with these settings right here. To get nice crisp lines, you see over here is kind of muddy in terms of color. You'd have to crank up the camera. Anti-alias is AA, meaning anti-alias. Right now set to 3. So basically, sampling is how sharp of a quality, overall quality your image is. Yeah, that's basically what this is. Right now it's set to 3. Each time you bring this up, your render times will pick up. So first it was set to 4, right? That's the base default. And then this one is when I turn on the imager, remember, the denoiser. And that did not include render times. This imager denoiser, I repeat, does not increase render times. It just helps to hide the flaky noise. Now this took 9 seconds, while this took 4, this took 9. Reason why it doubled in render time is because of when we added the secondary light bounces, 2 and 2. Increasing this went from 4 seconds to 9 seconds, okay? So this is what I want to show you. You see, I don't know if you notice, you see this? This is the anti-alias from what I can gather and what I learned. And see how it's kind of jaggedy over here? Like this. Well, this here also, the splotchiness is due to the denoiser causing this secondary, muddy look. In an effort to hide that, in an effort to hide this, it's gonna make some of this. That's what that is. And I'll press 1 to 1 in order to fix up this muddiness and to fix up this jaggedy edges here. What we'd have to do, first of all, what you could do is the brute force answer is to go back to your sampling, right? Arnold renderer, right? Render settings, camera AA. Ignore all of this for now. Instead of 3, if we set it to, say, I don't know, 7, okay? Alright, so I had paused the video because, like I said, the rendering is taking longer than like 20 seconds. It corrupts my file. Now if you notice now, you see how nice it is? How much more nicer it is? Do you notice? Right here. Versus here, it's all splotchy, just ugly, This was before, boom, this is after. Before, splotchy, after, much cleaner, much cleaner. Before, see, and after, much cleaner. And but if you also look, let me save this image again, this camera icon. This took 9 seconds. This took 44 seconds. So it went up exponentially, and that is because when I increase the camera anti-alias, meaning the jaggedy edges, from 3 to 7. That's what caused that massive increase. That. So camera AA will spike your render times and also your rate depth, which is your light bounces, right? 2 and 2. Another important note is later on, this thing here, when you deal with like glass and anything reflect like that has a lot of reflectivity and has like clear see-through glass and what you call refraction, you have to crank this up to like, I don't know, 4 and 4, 4 and 4 here, or 5 and 5. When you do that, your render times will also increase further because it has to calculate the additional light bouncing where the light is reflecting and bouncing off the glass material. That's what causes it. Rate depth. Alright, now I chose 7 because 8 out of 10 times a level 7 will give you a render quality that's acceptable for your demo reel. For render test, just leave it back to 3. Yeah. And I'm going to set it back to 3 now. Alright, so I set it back to 3. And here's my previous, which was 44 seconds. Very nice. And I'm going to let go of it. Here I'm back to level 3 camera anti-alias. And it's only 8 seconds. But still kind of ugly, you know, the splotch. So that's what that is. All you have to know is the default 3 for test renders. Crank it to 7 to get a nice crisp render that's you know, good presentable demo reel quality. This here, you know, at minimum 2 and 2, and at most 5 and 5. 5 and 5 for glass materials, refractive materials, something else called caustics too. Maybe caustics is something different, but yeah, that's what that is. And I think that's about it for now. Oh, also, when I talked about 960 by 540, right, the size, that is under your first tab for your render settings, your common tab, right? This one I should share up right now. It is under image size, common tab, image size, preset. Right now I'm set to HD 540, which is basically 960 by 540. Let's say if you want to go all out and you want to go to HD, HD is 1080. 1080 is HD, which is 1920 by 1080. But then, you know, for test renders, you could keep it 960 by 540. Yeah. One more thing, your render times are also heavily influenced by how powerful your computer chip is. So there's all different types of computer chips. My computer has, you could say top of the line, consumer grade. It's 16 cores, meaning there's 16 computer cores that'll process everything. So it has some good power to it. Regular computer these days have maybe like 6 cores, maybe 8 cores, and as a result of that, the render times take longer. So mine's would probably take, you know, more than half than what a regular computer would take. So if a regular computer takes about 10 minutes, mine would probably take about 4 minutes, something along those lines, per render image. Yeah. So that's pretty much that for now. Next video I'm going to talk about something else for lighting and rendering. Alright, bye.